Hello, it's been a while since I made a video and I wanted to provide an update. I also want to show how a flat earther's bias and cognitive dissonance led him far down the garden path by doing what he didn't. Proper research. But first, the final experiment in December completely shattered the flat earth community, and what remains of it lies in ruins. Pointing out the things that flat earthers get wrong is fairly easy, but trying to get them to acknowledge it is nearly impossible. Everything about flat earth got quite repetitive and eventually felt like trying to knock down a brick wall with a basket of tomatoes. Thanks to the events of COVID being a catalyst, flat earth brought me an opportunity to explore and learn new things along the way, like video production, and to show the results of my efforts. Deep down, however, I knew that the audience in most need of watching them did not and would not watch them, or any non-flat earth based video for that matter. After he gave up flat earth, Jaron voiced what I became convinced of many times over. Flat earth is well beyond cognitive dissonance. It's embraced as a lifestyle, and those who believe in it run and hide from anything that challenges their position with a drive and determination that would put any marathon runner to shame. There is absolutely no way they will watch non-flat earth videos. Since I seldom make videos for them, it did take on the feeling of preaching to the choir. Trying to find a balance between informative or entertaining without making it repetitive or a full-time job was nearly impossible. So I opted to make low production type videos that kept the views modest and left me with a bit of a Sisyphus complex. The last so many months were either a break or a chance to reevaluate my life choices, and I took a step back. It also didn't help that my main computer I was using for video editing developed a GPU fault, and it would take on randomly rebooting. I certainly have not run out of ideas for videos, but with the easy pickings called Flat Earth now behind us, and several factors like time, energy, and recent computer problems, you're now up to speed and what's been happening, or rather not happening. This video will, however, buck that recent trend as I hopefully tear a Flat Earther a new one. I was watching a not quite so recent now Simon Dan video, which led me on a rabbit trail that gave me what I thought would be excellent material for a new video. Simon Dan has been reviewing a video from SpaceBusters claiming evidence against a spherical Earth by pointing out the various discrepancies between the posted sunrises and sunsets and local solar noon times on several websites. The flat earther has also made a huge mountain over the discrepancies between which day the 24-hour sun starts or ends in Antarctica. This, therefore, for that flat earther must be proof that the tools are wrong, and somehow fudges a model claiming something that supposedly doesn't work. I won't go over any of the details from the other video other than to say that because timeanddate.com, dateandtime.info, and sunrise.maplogs.com don't all agree to the nanosecond for every single day and every single location, there must be something wrong with the model, and that the model cannot have any validity. Since that model has no validity, it must therefore, in the mind of a flat earther, default to a flat and stationary Earth with websites designed to fudge a flat Earth into the appearance of a globe. An entire hour and a half lost in the weeds in a video going over point after point, suggesting the sites did not only but could not agree with each other. He was oblivious to the fact that a simpler explanation was within reach. His entire argument was ultimately based on a fallacy. I believe the proper term is a straw man fallacy, but I'd like to call it I don't know how any of these tools work, and I don't want to figure it out, but trust me, they're all wrong, and it's a smoking gun that these laughable sites that can't be consistent with each other are deliberately manipulating everyone's perceptions to accept the globe fallacy. The real question, though, is which, if any of them, are accurate. How can 3 different websites give such wildly different days for a transition to or from 24-hour days in Antarctica, and which one is really the right one? The answer is both simple and obvious in context. What is the definition of daytime? When any portion of the sun is visible? When it's fully visible. If you don't see the morning sun at the base of a mountain, but you do see it further away at the same time, is it still dawn? Maybe the differences are expressed in subtle ways that are mainly subjective rather than objective. Instead of focusing strictly on bases in Antarctica, which, when I started this side project, were in 24-hour night and or twilight, I started with a simple question. How closely do they agree for a reasonably populated city? I chose New York and instantly got a bad feeling that the websites chosen were not the best ones to raise as a standard of authority and accuracy. It was bad enough that timeanddate.com and dateandtime.info had two different posted day lengths, but I also noticed that dateandtime.info had a different local solar noon time than timeanddate.com. The coordinates given for both were quite close together, so to have a 5-minute discrepancy meant one or both of them were using simplified algorithms or outdated lookup tables. This lacks the precision and fidelity of reality that caused our flat earther to almost have an aneurysm. I've had a fair bit of experience with the formulas used in the NOAA Solar Calculator spreadsheet, so I decided to compare the two websites against that. Apart from the sunrise and sunset times disagreeing by some minutes, the local solar noon matched for timeanddate.com. And equally important, the difference in the day was evenly spread, so an extra few minutes of sunrise reported by the website was also mirrored with a few extra minutes after sunset. I tried a few other locations and a pattern, even a clue emerged. Forgetting for a moment that New York local solar noon was skewed for dateandtime.info, the other sample locations I chose were much more in agreement, so I considered the local solar noon issue as an independent issue from the main pattern I saw, and likely dealt with an error in the data set that dateandtime.info uses. Apart from that, what else emerged from my sampling? Dateandtime.info always reports the day length as being longer than timeanddate.com. This is a very important pattern that helps invalidate the examples cited by our flat earther, and more attention to this should be given. First, let's review how NOAA calculates sunrise time. The native coordinate system of celestial objects is declination and right ascension, which works very much like latitude and longitude. All stars that have a specific declination will at some point during the day or night be over the ground position of the corresponding latitude. The sun, like everything else in the sky, passes your local longitude at a specific time. But when you first see the sun in the morning depends on many factors. Your latitude is the main one, but is there a mountain in the way? Or are you on a coastline? We have an atmosphere which refracts the light so you don't see the sun where it really is, but where it has already been refracted to appear through the atmosphere. Do you consider sunrise when you first see the top of the sun, or when it's no longer obstructed and you see the entire disk? Is it a compromise when the sun is half visible and the remainder is still obscured by the horizon? A very close examination of the NOAA Solar Calculator spreadsheet, and by extension the two main websites mentioned by our flat earther, will, and I will show later, reveal that the way sunrise is calculated is both brilliant and simple, although the precise definition of each has its own subtle definition of when the sunrise happens. The sun has an average angular size of about 0.53 degrees. If we imagine that the very top of the sun's disk touches the horizon at sunrise, which acts like a tangent line to the curve of the sun, that would be a sort of epoch, where any moment after that means part or all of the sun has crossed that threshold and direct sunlight is possible. The NOAA Solar Calculator works out that time by dealing with an hour angle relative to local solar noon. So it subtracts 90 degrees plus an additional amount to lower the sun to be at that point. The value found in the NOAA Solar Calculator spreadsheet is 90.833 degrees. If that value in the spreadsheet defines the sunrise time, at the equator during an equinox, the sun rises straight up and has a very small margin for error. At 15 degrees per hour, every tenth of a degree in that calculation would make the sunrise appear to be off by about 24 seconds. The margin of error becomes more of a problem as you go further and further north or south, because now the sun is not rising straight up, but at a shallower and shallower angle. Any discrepancy in where the epoch happens is compounded until it can be off by many minutes, or perhaps even days if you are close enough to the poles. Having spent quite some time observing the motion of the sun, moon, stars, and planets, and modeling it for anywhere on Earth, it became very easy for me to see how the websites differed from the NOAA Solar Spreadsheet Calculator. The only trick left was to obtain enough data points to quantify by how much. Back to the first sample. I calculated the difference in daylight between the two sites, divided that by 2, and subtracted that time from the NOAA spreadsheet computed sunrise time. I then worked out what the sunrise hour angle should have been for dateandtime.info to match that sunrise, and when I compared that hour angle with other locations, the primary conclusion was that they defined a sunrise with a larger sunrise hour angle than NOAA or timeanddate.com. Note that the NOAA Solar Calculator spreadsheet uses the sunrise hour angle of 90.833 degrees, but when I used 91.4 on the small sample set, I was able to get very close to the sunrise and sunset times on dateandtime.info with 6 different locations from 66 degrees north to 53 degrees south. I felt I was very close to an explanation for the differences even with this very small sample set. Fast forward to where I am now, I calculated a new spreadsheet that is based on the NOAA Solar Spreadsheet Calculator, which I will make available. Check the description for a link. And I have included enough different times and locations I can confidently show that every location on each website can be reverse engineered to within a few minutes error, with a caveat I will address shortly. The error in accuracy is mainly due to the lack of precision on those websites that show only hours and minutes. The third website mentioned, sunrise.maplogs.com, that I didn't spend a lot of time checking, seems to display the day in its tables expressed in UTC, so all locations west of the prime meridian should be consistent with the other two websites. However, when a sunrise or sunset occurs near midnight, which by the way happens mainly closer to the polar regions, or when a local time is far from its longitude, locations east of the prime meridian can appear to be a day behind, specifically addressing the issue of which day the 24-hour starts or ends. A few last discrepancies to account for, which I don't think I will try to resolve at this time, relate to what time of the day sunrise or sunset happens. The algorithm used by NOAA uses the sun's instantaneous declination in its formulas to compute the sunrise hour angle, and with the sun's declination always changing, the moment-by-moment sunrise hour angle also changes throughout the day. Websites don't want that sort of ambiguity, so from my findings, it appears as if they use the day's local solar noon time to derive the sunrise sunset times. If local time differs significantly from the longitude's local solar noon time, sunrise and sunsets can both happen in the AM or the PM, and that causes sites like timeanddate.com or dateandtime.info to display the wrong day's sunrise time. Another discrepancy involves the way local solar noon is computed and how dateandtime.info can be off by 5 minutes for New York from timeanddate.com, given the coordinates provided match to the angular minute on timeanddate.com. New York in this case only had degrees and minutes, but not seconds. The primary cause of disagreements between the formulas I created by reverse engineering the websites and the sites themselves remain in the use of hours and minutes on those websites, and in polar regions where the sun hardly changes altitude angle throughout the day, so computing the moment the sun rises above an altitude angle threshold such as minus 0.49 degrees can greatly compound very slight differences, such as using 12:05:17 as local solar noon rather than the ambiguously reported 12:05 p.m. If we define sunrise as the refracted sun's altitude angle and the extremely shallow altitude angle changes over time, choosing many significant digits and fitting them into a posted time with a 60-second precision becomes quite a challenge. Overall, having scraped over 960 location versus date-time combinations from dateandtime.info and about 860 from timeanddate.com, when I use the horizon as the daytime marker and focus mainly on days where there is no 24-hour sun or 24-hour night and avoid the day before or after the transition, the far majority in that set works out to less than 4 minutes difference between my computed and their posted times. A lot of them are within a minute. A few of those work out to 15 minutes discrepancy, give or take a few minutes. Every one of them is in the spreadsheet, so feel free to review them and review the math. To summarize, I have characterized 3 basic differences between the 3 sites that are flat earthers cited. The first, timeanddate.com, is the closest I found to the NOAA solar calculator and is probably the most accurate overall. Its primary difference is in the local sunrise hour angle, but it's still quite close to the NOAA solar calculator spreadsheet. The second, dateandtime.info, is also very close to NOAA, but it defines sunrise and sunset when the sun is lower than the others. So rather than being about 90.8 degrees, they define the sunrise hour angle of about 91.1. This naturally has the effect that specific days reported in polar regions appear to be longer and will often manifest as an earlier transition to 24 hours in November or December and a later transition from 24-hour days in January or February. This is ultimately an arbitrary threshold and is equivalent to saying that a room for one person is quiet but not for another, based on each person's sensitivity to sound. The noise in the room has not changed volume, only that each person's perception and ability to detect it is different. The third site, sunrise.maplogs.com, appears very similar to timeanddate.com. However, one needs to be aware that from a very small sampling of locations I made, the days displayed in its monthly tables of sunrises and sunsets appears not to be local times, but appears to be in UTC. So it can appear to be one day behind the others for some locations, but not for all. For example, Antarctic Logistics and Expeditions uses UTC-3 for their time at Union Glacier and would match the other 2 websites. But McMurdo Station is UTC plus 12, which would be reported as a day earlier. If you watch the Flat Earther go over every single point and apply those differences in his examples, you can see very quickly that there is no problem at all and his entire 90-minute plus tower of evidence falls over. An appeal to ignorance fallacy or incredulity fallacy is not a valid argument. For all the talk of problems and discrepancies, the 3 websites remain consistent with the globe. Once all the very silly things like hour angle and time zones and dataset errors and simple plain old edge case handling bugs are factored in, and once again what seems like a smoking gun does not support flat earth at all, but contradicts their own argument. That's going to be it for now. As always, thank you for watching, and if you've made it this far, I'm very appreciative. If you found this useful and informative or entertaining, a thumbs up and comment is always encouraged. Bye for now.